Hello everyone, welcome to this video. In this video we are going to solve question from December 2012 consisting of 3 marks. The question is, let j of u is integration from 0 to 1 ux square plus 4u square by x square x into dx, where ux is a smooth function defined on the closed interval 0 to 1 satisfying u of 0 is 0 and u of 1 is 1. That is, in this question we are given fixed boundary conditions, right? So this is the simplest of all variational problems. So we need to suggest which of the following minimizes j. So we need to tell out of these 4 which is the solution. So let us get started. Let us first write the Euler-Lagrange equation. What is that? For that you must determine here u is the dependent variable and x is the independent variable, right? So what would be our Euler equation? That would be f of u minus d dx of fux is equal to 0. So let me write what is f. F is ux square multiplied by x plus 4u square divided by x. So let me calculate its derivative with respect to u. What would be that? It would be 0 plus 8u divided by x, and f, the partial derivative of f with respect to ux, that would be 2ux into x. That's it, right? So let us plug in these values over here. So let's see what we get. We have 8u divided by x minus d dx of 2ux multiplied by x is equal to 0. So I can take 2 common from here. So I'll have 4u divided by x minus, here I have to apply product rule. So what would be that? So the first derivative, second function as it is, plus first function as it is, derivative of second, that would be 1, right? So I have 4u minus x square uxx plus x into ux is equal to 0, or I can write this as x square uxx minus x into ux minus 4u is equal to 0. Now this is the second order ordinary differential equation with variable coefficients, and in particular with second derivative we are having x square, with first derivative we are having x, and with u we are having constant, right? So such kind of equation is known as Cauchy-Euler equation. You must have read about these in your course on ordinary differential equations. So how do we solve these kind of equations? To solve such equations, what we do, we make a substitution such that we replace the independent variable x with z. So x, I am substituting x is equal to e to the power z. So I have z is equal to log of x. So this gives the this replaces the term x square uxx with d into d minus 1, where what is this d into u, where what is this d? D is the derivative with respect to z, and the term x ux with d into u, right? So let me put these values into this equation. So I have d into d minus 1 minus d minus 4 into u is equal to 0, or the auxiliary equation gives me d square minus d, here it should be, no, it's fine. So d square minus d minus 4 is equal to 0, right? Here it should be minus, right? Yeah. If it is minus, so it is plus. So we have a plus sign over here. So this d and d cancels. So we have d square minus 4 is equal to 0. So this gives me d is equal to plus minus 2. If d is plus minus 2, then the function corresponding the u of z, because now we have substituted in terms of z, right? So u of z is if d is equal to plus minus 2, we have c1 e to the power minus 2z plus c2 e to the power 2z, right? And let me substitute back the value of x. So we have substituted x is equal to e to the power z. So let me substitute it back. So it will give me c1 x raised to power minus 2 plus c2 x raised to power 2. So this is u of x, right? So this is the function that we required, but now we have to calculate these constants, which are c1 and c2, right? So let us use the given fixed boundary conditions. So we are given boundary condition at the end point 0 and 1, which is u of 0 is 0 and u of 1 is 1. So let me substitute these values. What I get is u of 1 is equal to 1. This gives me 1 is equal to c1 plus c2, or I can write c1 as 1 minus c2, right? So now my u becomes, I'm substituting this value in this, so u is equal to, in place of c1 I'll write 1 minus c2 multiplied by, divided by x square plus c2 into x square. So I have, if I take this x square onto the left hand side, I'll have u x square is equal to 1 minus c2 plus c2 x raised to power 4. So I have u x square is equal to, I can take c2 common, so I have minus 1 plus x raised to power 4 plus 1, right? So now let me substitute another boundary condition, u of 0 is equal to 0. So what I get is 0 is equal to minus c2 plus 1. So this gives me c2 is equal to 1. If c2 is equal to 1, this gives me, I'm substituting the value of c2 in this equation. What I get is c1 is equal to 0. If c1 is 0, c2 is 1. So what my solution is? My solution becomes u is equal to x square, right? So let's have a final look at our options. So this is the solution, right? So our given options are u is equal to, just a second. So our given options are u is equal to x square, u is equal to half x square by 2, half x square, 1 by 4 x square. So clearly option 1 is the correct option. So this was a very simple question. I hope you have understood it. Thanks for watching the video. Please subscribe to our channel.